Okay. All right, here we go. Here's what we have for today, combining like terms. And like I said over here, at the end of today, you should be able to recognize like algebraic terms, and you should be able to simplify algebraic expressions containing like terms. That is the goal for the day for you to learn. All right? So, first question. What are terms? What are terms?
Terms are like 3x or 3x squared or 3a squared b.
Okay, all right.
Or anything with a variable.
3x, 3x squared, 3a squared b. Those are all terms, okay? Those are all terms, and that is correct, all right? And I'm going to throw out another tidbit of information here, and I would probably jot this down, okay? Terms are separated by pluses and minuses. Terms are separated by pluses and minuses. Okay? So, keep jotting that down. Terms are separated by pluses and minuses. You kind of see what I've got in red there? You take a look up. Terms are separated by pluses and minuses. Okay? 2x squared is a term. 3x is a term. Negative 4, right? We talked about this the other day. A minus sign and negative sign kind of one and the same. That negative 4, that minus 4 is another term. So how many terms are in this expression? How many? 3. There's 3 terms there, okay? Terms are separated by pluses and minuses.
If they're separated by pluses and minuses, what about like multiplication and division?
Well, they will be you'll have some separate terms there, but in general, terms are generally separated by pluses and minuses when we're talking about algebraic expressions, okay? So, for instance, let me give you this example right here. For instance, right here, sometimes I'll ask students, I'll go, how many terms do you see right here? And some students will say 4. It's like, okay, what are the 4 terms? They'll say, oh, 2, x, y, and z. There's 4 things there. That's 4 terms, okay? Again, pluses and minuses are going to separate the terms. This right here, 2x, y, z, is 1 term. There's no pluses and minuses there. There technically is multiplication, though. Because really, that's 2 times x times y times z. So terms are separated by pluses and minuses. That 2xyz would be 1 term. That is what we would call, we're not going to get into this in depth right now, but that would be a monomial, right? A monomial. Mono meaning 1. That's 1 term. Okay? So I think that's important for you guys to understand initially is, because we use that a lot, terms. What is a term? A term is a expression, and they are separated by pluses and minuses. Okay? Are we okay with this? Okay. All right. Okay, so then we go to the next step, and we say, okay, what are like terms? And we had something on the warm-up today that kind of alluded to this a little bit, okay? Like terms are going to have the same, starts with a V.
Variable.
They're going to have the same variables with the same exponents. Like terms they are terms with the same variables and the same exponents. So 3x and 2x. If we look at those as 2 separate terms and we said, hey, are those terms like, we would look at that and say, okay, do those terms have the same variables? Yes. With the same exponents. Technically, what's the exponent with the x? Technically, there's a little 1 there, isn't there? Okay? So, take a look at this. Would these terms be like?
Yes.
Do they have the same variables?
Yes.
Yes. Do they have the same exponents? They don't.
One is x squared y.
Yep, exactly. X squared here, single x here. Y here, y squared here. They do have the same variables, but they do not have the same exponents, so therefore, these terms right here are not like. Boy, it sure looks like they are, and we say, hey, they both have x's and y's, correct, but guys, we've got to check the exponents too. Got to check the exponents, all right? We okay with this? Like terms are separated by pluses and minuses. Those terms have got to have the same variables with the same exponents. Okay? By the way, back up here in this little first example there, that big 3 and that big 2, the algebra, you don't necessarily need to write this, you can if you want to. That big 3 and that big 2, any number in front of the variable, and I refer to them as big numbers, technically they are called coefficients. 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 So that big 3, any big number in front of a variable, okay, is technically called a coefficient. And again, a lot of math is vocabulary, guys. If we can get used to the vocabulary, we can understand kind of what they're talking about. But I refer to those a lot of times as big numbers, but those are coefficients. Exponents are those little bitty numbers to the upper right of any variable, any number, okay? So far, so good? Everybody good?
Still right.
Okay, that's what I need to know. That's what I need to know. Guys, if I get to going a little fast, you just raise your hand, say, Mr. King, would you please slow down? Big guy, slow down. Okay? I just get so excited about teaching. Christian.
Can you please repeat the part about coefficient and so forth so I can write it down?
The coefficients are your big numbers in front of variables. Big numbers in front of variables are your coefficients. Technically, what's the number in front of this x squared y? 1, okay? Understood ones. Be careful of those understood ones because it's the one number that can be understood. It can be understood as a coefficient number. It can be understood as an exponent, right? So just understanding that those understood ones are there, okay? All right, we good? Okie dokie. Good job. All right, so we're going to go... if you want to jot these down, that's fine. And again, I'm going to try to upload this so you can have access to it to view at a later date or later time. This is pretty much yes, no. 3x and 2x, are they like? Yes or no? Yes. How about 4y and 5y? Yes. Do the terms have the same variables with the same exponents? That's what we're looking at. Like terms comes down a lot of times to just variables and exponents, guys. What about 2x squared and 5x squared? Yes, I agree. What are the coefficients of those two terms? Perfect, 2 and 5. Okay, so again, just knowing what we're asking about is a huge hurdle to get over. Once we kind of know that vocabulary, we know what we're asking for, right? Okay, what about 3xy and 6xy? Yes or no?
Yes.
Same variables, yes or no?
Yes.
Same exponents?
Yes.
Like terms?
Yes. Yes.
Say it with conviction. Yes. Absolutely. Yes, those are like terms. Guys, I want you to speak with conviction. Okay, if you give an answer, give it. Okay, if it's off a little bit, let's talk about it. All right, do not be afraid to be wrong. Go with your gut instinct here. Okay, how about 5x and 3z?
No.
No. Everybody good with that? That is a no. Obviously, two different variables, right? Two different variables. How about 2x squared y, 3xy squared? Yes or no?
No.
Why?
Because the variable is the variable, right? No, that's not that.
You good?
It's the exponent. It's the exponent.
Good, good. It's the exponents, right? Do they have the same variables? Yes, but do those variables have the same exponents? No, and that's what kicks that dude out, okay? So this is a no. All right? But again, just kind of training the eye. If we're looking for like terms, we're training those eyes to try to pick up variables and exponents. It's got to be both. Because again, as you can imagine, easy mistake to make, and that's what some students do. And again, guys, it's normal. It's normal. We see xy, and we think, yeah, like terms, same variable. Check those exponents. Okay? Questions? Any questions about any of those examples right there? Can you recognize like algebraic terms? Yes. Okay, so we're checking that right now because in order to add and subtract, we've got to recognize them first. Okay, so far so good? Okay. All right, so this is pretty much, I've got some examples here of what you're going to see in your problem set today. Okay, this is what kind of the nuts and bolts of the lesson they are. Can we add and subtract? Can we combine like terms in an algebraic expression? Okay, so let's take a look at the first one. Read it to yourself. Somebody read that first one for me. Raise a hand, go.
12x minus 5x.
There you go. And guys, that's what you want to be saying to yourself. 12x minus 5x. Do we have like terms?
Yes.
Yes. Are we allowed to combine these into one term?
Yes.
Yes. What is 12x's minus 5x's going to give us? How many x's?
7? No, 7.
Say it with conviction.
7.
7x. Right here, this is going to simplify to 7x. If I take 12 apples and I subtract off 5 apples, I've got 7 apples left. Instead of apples, we're dealing with the variable x here. So 12 x's, take away 5 x's, we've got 7 x's left. Single term. That is one term. That's a one-term answer. Everybody good with that? Let's go to the next one. Go to the next one. Can I get a volunteer to read the next one, please? Christian, go. What do you think?
2 plus 3x minus 4.
Fantastic, okay? And guys, again, it's important that you're reading it, okay? Christian read it out loud, and read this to yourself. 2 plus 3x minus 4. Now, are all the terms like?
No.
They are not. Which terms are like? Go.
The 2 and the 4.
The 2, and what kind of a 4 is that?
That's a negative 4.
That's a negative 4, okay? So,
Plus negative 4.
and like I mentioned the other day, it really doesn't matter what you do first. If you recognize the 2 and the negative 4 as like, and you want to deal with that first, then let's do it. What is 2 minus 4?
Negative 4.
Negative
2. I meant
2. We're good. We're good.
2.
Negative 2. Negative 2. So the 2 and the negative 4, we got those taken care of. We have combined those to make a negative 2. What's the only thing left? What's left in that expression that's unique? 3x. Is that 3x positive or negative? It's positive. So here's what we're going to do. We're going to put a plus 3x right behind that negative 2. Negative 2 plus 3x. Negative 2 plus 3x. Everybody okay with that? Guys, if you have a term that is unique and there's nothing else like it, it's just going to be part of your answer. Okay? Now, would this be just as correct if I wrote it 3x minus 2? Is that the same answer? Is the 3x positive in both answers? Yes or no?
Yes.
Yes. So we're good there. Is the 2 negative in both answers? Is this 2 negative?
Yes.
If I cover up this 3x, is that 2 negative?
Yes.
Remember, the minus sign and a negative sign are pretty much one and the same as far as identification of positive or negative. So these two are the same, okay? You could write that either way and you would be correct. Okay? And like I said, normally this is typically what you would see like in a textbook or, some of these things where you're looking at answers, multiple choice kind of stuff. So this is typically in yellow what you would see. If you wrote it over here, what we have in red, negative 2 plus 3x, guys, that is just as correct. It's just in a little different format. Okay? All right, let's go to the third one here. Somebody, yes, sir.
Negative 3 plus 2x plus 4 negative 5y.
Okay, read it again. Doing good. Negative
3y plus 2x plus 4 minus 5.
Minus 5y. Good. All right. And what I like about that is he's already recognizing that minus 5y is going to really be kind of like a negative 5y. But as we read it, we're probably going to pick it up like a minus sign. Okay? Good job. So negative 3y plus 2x plus 4 minus 5y. Which terms are like? Go.
Negative 3y and negative 5y and minus 5y.
Okay, and minus 5y. Okay? Everybody okay with that? Make sure you're picking up the signs. Okay? Okay, what is negative 3y minus 5y? What is negative 3y minus 5y? Go.
Negative 3y minus 5y is negative 8.
Negative 8y. Negative 8y. So again, those darned integers, okay? Those integers just don't go away. And I'll try to probably keep some of those on the warm-up just to kind of keep us going with that. Are there any other x terms? Yep. Are there any other terms with x other than 2x?
No.
There's not. So 2x just becomes part of our answer. Plus 2x. Just tack it onto the answer. It is unique. Okay? If we have a term that is unique, we're good. And what's the last thing left? What's the last thing in there that we haven't done anything with? Plus 4, right? Just part of our answer. Any term that is unique, it is just going to become part of our answer. So that should be a final simplified answer, negative 8y plus 2x plus 4. And guys, you could rearrange those terms. You could write it 2x minus 8y plus 4. You could write it 4 minus 8y plus 2x. So those terms can move around in different orders, okay? But those signs need to stay the same. The 8y needs to stay negative. The 2x needs to stay positive. The 4 needs to stay positive. But you've got a little bit of flexibility there, okay? Any questions thus far? All right, you guys are doing good. Stay in there. A couple more examples here. Okay, let's take a look at this next one. How many terms are in this expression? How many terms in this expression?
There are 4 different terms in that expression.
There are 4 different terms, right? 6x, negative 2y, positive x, and negative 1y, right? And again, recognizing terms for what they are, terms are separated by pluses and minuses, okay? All right, so in this one here, which terms are like? What have we got that is like? Somebody's trying to get maybe somebody different. Christian, go.
Well, the terms that are like are the 2 x's.
Okay, so those 2 terms are which ones?
6x and x.
Perfect, okay. Are there any other terms that are like? We know the x's are like.
2y and y.
Okay. Now, this is a strategy, and I'm just going to share this. I'm just throwing this out there. It's nothing you have to do. But sometimes when you guys are collecting like terms, some students that I've noticed use a strategy where they go through and like I've put little squiggly lines underneath the X terms and I've boxed in my Y terms. So some students will use a visual cue to identify which terms are like. So now visually it might be better for them to go, okay, now I'm seeing which ones are like. I know what I'm going to combine. What is 6x plus 1x? 7x. 6x's plus one more x. Guys, I've got 7x's. Boom, got it. How about negative 2y minus 1y?
Negative 3y.
Negative 3y, I agree. Same sign, keep the sign, add the numbers, right? 7x, I got you. 7x minus 3y. 7x minus 3y. Is that the same answer that I just wrote up there in blue?
Yes, only in a different format.
There you go. Negative 3y plus 7x. Guys, same answer. Same answer. You have some flexibility in moving these terms around. The signs have got to stay the same, though. Okay? So sometimes on a multiple choice test, you get an answer, you're looking for your answer, and you're going, hey, I don't see my answer. The terms might be in a different order. Okay? So be prepared to possibly change the format of your answer. Okay? All right. Last one here. How many terms are in that expression? Traylon, go, bud. There's 4. Okay? This time, rolled in some exponents here. Which terms are like? Which terms are like? Oh, I'm sorry. How are you today? Good to see you. Okay, Traylon, go.
12x squared and 2x squared.
Good. Is the 2x squared positive or negative?
Negative.
It's negative, isn't it? Okay. Are there more terms that are like?
X and 5x.
3x
And
and
negative
5x. Both of them are negative, aren't they?
Yes.
Okay. So again, I'm trying to mark my like terms a little bit differently. So I'm kind of giving myself a visual cue as to what is like and what's unlike. All right, so here we go. 12x squared minus 2x squared would be, go big guy. Yep.
Negative 10x squared. No, 10x squared.
Good. 10x squared. 10x squared. 12x squareds, take away 2x squareds is going to leave us with 10x squareds. Boom, got it. Negative 3x minus 5x.
Negative
Negative
8x. Negative 8x.
negative 8. Trail, what'd you have?
2x.
Do what? Right here? Y. It's negative 3y. That's a y. You'll learn my handwriting. I know. You'll figure. Huh? 10x squared. 10x squared. Yeah, it'll just take you some time. You'll figure out my handwriting. You'll decipher it. All right. These two terms right here, negative 3x minus 5x, are they both negative?
Yes.
Yes. Same sign. Keep the sign. Add the numbers, right?
Right.
Negative 8x. So minus 8x. Okay? I know, those darn integers. Okay? And we'll get it. Like I said, hey, throw out an answer, go with it, be convicted about it, and if we need to adjust, we'll adjust. And like I said, I'll keep some integer stuff on the warm-up for a while to kind of just get us back in that integer loop again. Okay? All right? What do you guys think? Questions? Can we do it?
Yeah.
Can we do it? Okay, so now we should be able to, hopefully, by the end of the day, and we get a little practice in, simplify algebraic expressions containing like terms. That's what we just did here, okay? So, guys, basic stuff. We've got to have a foundation for the basic stuff in order to do things down the road a little more difficult, okay? Got to have that foundation. So, hopefully some of this seems simple. Hopefully some of us are going, okay, good, I need this. We need a little refresh, all right? That's what this is all about, all right? Terms are separated by pluses and minuses. Like terms have got to have like variables with the like exponents, all right? And then being able to look at these things like this and just identify what is like and say, okay, I'm bringing those things together, and then those integer rules are just, they're always around, okay? So do not be afraid to make a mistake, all right? Now, you're going to find in Canvas, okay, I think you're going to find in there, I think I've got it dated 8/16. I think it says combining like terms. You should be able to click on that, and it should produce the worksheet for the day. Okay, should produce the worksheet for the day. We are going to do, guys, there's 14 problems there. Okay, that's not many, all right? And we're doing a pretty basic skill here. We just need the reps. We need the reps, okay? So on a separate sheet of paper, this will be a paper pencil. This will be paper pencil. On a separate piece of paper, you guys are going to go 1 to 14 all. Okay, we're going to go 1 to 14 all. So we're going to try all 14. Pardon?
So we're showing our work?
Yep. Now, some of these, there's not going to be much work to show. You're pretty much just collecting like terms, okay? On a separate sheet of paper, we're going to do all 14. Yes, ma'am. Question. When that pass comes back. Yep.